The last part of this section has us solving equations and inequalities involving fractions. So what we will do in order to solve both the equations and the inequalities at the same time is we will draw their graphs by setting them equal to 0 on one side and as one fraction on the other side. So to actually graph these fractions, what we will do is we'll worry about a couple of things. We'll worry about number one, when is the top equal to 0 for our fraction? And when is the bottom equal to 0? And we'll figure out what those two things mean. We'll draw them in, and then we'll test a couple of values to fill in the picture of our graph. Because when we're solving these inequalities, if we set the one side as 0, then we're just worried about whether or not our graph is above the x-axis, meaning greater than 0, or below the x-axis, which means less than 0. So let's take a look at our first example, number 1, and we will solve A, B, and C all at the same time. So notice our main requirement is that we have one fraction on the left and 0 on the other side. We already have that. So if we do, we're going to just jump to looking at a couple of things. We're going to look at number 1. When is the top equal to 0? When is the top equal to 0? Well, the top is equal to 0 when x plus 1 equals 0, which happens when x is equal to -1. Well, what will this be on our graph when we go to draw it? Well, here's x equals -1. This will be where the top is equal to 0, means when the top of a fraction is 0, it means the whole value of the fraction will be 0, which means that will be where you cross the actual x-axis. This will be a point. The second part that we want to look at is when the bottom equals 0. We talked about this previously in this chapter. When the bottom equals 0, when x minus 4 equals 0, happens at x equals 4. You find that out by adding 4 to both sides. But when the bottom equals 0, that's when we end up with what's called something special. It's called a vertical asymptote. So I'm actually going to draw that as a vertical line so that I remember that this is an asymptote. Asymptotes are always drawn as dotted or dashed lines so that you know that you're not going to actually touch it. Now what this does is this automatically breaks my graph into 3 regions. It breaks it up into what's happening before -1, what's happening between -1 and +4, and what's happening after +4. So what I would like to do is test a value in each one of those 3 sections. So again, my first section is whatever's happening before -1. Then my second section is what's happening between -1 to 4. And my third section is what's happening after +4. So we're going to pick 3 values, one from each section, and we want to find out what's happening in those sections, whether or not I'm above the x-axis, meaning am I greater than 0, am I positive, or am I below the x-axis, am I negative, am I less than 0. So let's pick one value from each of the parts of the graph, the 3 parts. So first thing, we want to look at something from the first section, meaning something less than -1. Let's test, let's pick, you get to pick. I'm going to plug in a -2. Remember, we're plugging it in to our function, which was x plus 1 over x minus 4. So if we plug in a -2, it'll be -2 plus 1 over -2 minus 4. And again, I don't care what the actual number is. All I care is whether or not it's greater than 0 or less than 0 so that I can figure out if I'm above the x-axis or below. Well, notice on top I get a negative and on the bottom I get a negative. Well, a negative divided by a negative will actually get me a positive number as my answer, which means I'll be above the x-axis, which means I'll be somewhere up top in that first region, before -1. Now, let's test something in the second region between -1 and +4. I'm going to pick the easiest, I think, is 0. So plugging in 0, again, to the same function, x plus 1 over x minus 4 will give me 0 plus 1 over 0 minus 4. Again, I don't care what the actual number is. All I care is whether or not this is going to be greater than 0 or less than 0, positive or negative. Well, on top, I end up with a +1, and on the bottom, I end up with a -4. Well, a positive divided by a negative is always going to give me a negative, which means in the second region, if it's negative, it means I'm going to be below the x-axis, heading towards my asymptote. So far, I've got a pretty good idea what my picture is doing. I just don't know what's happening in my third region. I, again, have to pick a value, plug it in, and test it. So in my third region, I am wondering what's happening after 4, so I'm going to plug in 5. Plugging in my value 5, I get 5 minus 1 on top, 5 plus 1 on top, over 5 minus 4 on the bottom. Again, let's see what kind of answer I get. I get a positive on top divided by a positive on the bottom. Well, positive divided by a positive will still get me a positive. Well, that means that that last part in region 3 is going to be all positive, meaning above the x-axis. I won't know exactly what it's going to look like, but it's going to be something up above like this. Now, this allows me to actually answer all 3 questions, A, B, and C, all at once because I have my picture. In A, the question is, when do I actually equal 0? Well, I equal 0 in A when I cross the x-axis, which according to my picture is happening when x equals -1 only. So my answer to A is just the answer -1. B is asking, well, let's see, what is B actually asking? B is asking, when am I greater than or equal to 0, meaning when am I above the x-axis? Well, I'm above the x-axis in the third region and in the first region. So how do I write that out? Well, I have to start out with the first region because I'm reading this from left to right. So I'm going to start with -infinity on the left and working towards -1. And then my other part is region 3, which starts at 4 and goes towards positive infinity. The question is, what are the symbols I'm going to use at -1 and 4? Be careful. Yes, we do have an equal to here in B, but no matter what, we have an asymptote here at 4. Because we have an asymptote here at 4, no matter what, you should be using a parentheses here at 4. We can, however, use a bracket at -1 because that is not an asymptote. That's just a point. Because of the equal to, because we have just a point, I can use the bracket at -1. Now I need to put these 2 pieces together, so I will put a little union symbol in between, and we are done for part B. Now with part C, we're asking something different. When am I below the x-axis? When am I negative? Well, that happens in region number 2 here. We can see. So how am I going to write that out? Well, that'll be starting at -1 and goes all the way to +4. Now, notice, no matter what kind of problem we have, 4 will always be a parentheses because it's an asymptote. What happens at -1 is going to be determined on the problem. Well, -1, well, according to our problem in C, we have just a less than, not an equal to, so we will use a parentheses, not a bracket. So that is all 3 answers to A, B, and C.